Okay, so the purpose of this video is going to be to introduce to you limits at infinity. The video following this, the kind of part 2 video to section 3.5, is going to be where the majority of the math is done. So please do make sure to follow up with that one. So we talked about limits early on, and remember that we use the symbol of the arrow to mean as it approaches. So this is saying that as x approaches 3, my function approaches infinity. So that means that if it's approaching infinity, we're going to have a vertical asymptote at 3. Now we're basically going to flop and say, instead of approaching a number, instead of us approaching a specific value, what's happening at the very end of our function, whether that's infinity or negative infinity. Often it's referred to as the end behavior of a function. But so as my x values get really, really big, what is my function approaching? What's happening again at the end behavior of my function? So if it were to, for example, they're not all going to look like this, but if I had said x approaches infinity, f of x approaches 3, that would imply that if I'm approaching that y value of 3, that I have a horizontal asymptote there as opposed to a vertical asymptote. So here would be a picture of that representation. So I don't know what's happening with my function early on, but as I get larger and larger, I'm approaching a y value of 3. How do I determine if a horizontal asymptote exists? It exists that because the limit as x approach infinity, if it approaches a number or as it approaches negative infinity, if it approaches a number, that means that number it's approaching is a horizontal asymptote. So that's one situation that occurs. A couple other things to point out, or a very big definition in calculus to point out. Notice that I have this filled in, these kind of two charts. If I look at this first chart, notice as I start dividing 1 by larger and larger and larger numbers, the value I get gets smaller and smaller and smaller. We're going to interpret that by saying, if I divide 1 by infinity, I'm going to be getting towards 0. It's not just 1, it can be any number. For example, if I took a number much larger than 1, say 300, notice I get the same result. As my values that I'm dividing by get bigger and bigger and bigger, my value that I'm getting is smaller and smaller and smaller. Therefore, in the same aspect of 1 divided by infinity, 300 divided by infinity is still going to be 0. So that brings us to a theorem about limits at infinity. If we have any value on top, any constant on top, if we divide by a number and we are saying that that number is approaching infinity, so that number is getting bigger and bigger and bigger, we're going to reach a limit of 0. So basically what that's telling us is that if we divide something in an infinite amount of times, we are going to be approaching 0. Think, for example, if you have a pizza that you're going to divide among 10 people versus 100 people versus 1,000 people versus 1,000,000 people. If you try to divide a single pizza by 1,000,000 people, it's not even going to be worth it. You're going to get such a small amount. You're essentially going to get nothing from that pizza when it comes time to give you your share. That's what that's saying. We can use direct substitution. So real quick, looking at these two examples, we can use direct substitution with infinity just like we can use direct substitution with numbers. We just think of infinity as a very, very large number. So if I look at this, if I have the limit as x approaches infinity of 5 minus 2 over x squared, remember we've already learned that we can break limits up. So the limit as x approaches infinity of 5, well, I'm going to be 5 no matter what, minus the limit as x approaches infinity of 2 over x squared. Well, if I plug infinity in, according to my theorem up here, when I divide 2 by extremely large numbers, that's going to drive towards 0. So I get 5 minus 0 does equal 5. And looking at my second example, if I take the limit as x approaches infinity of 3 times x squared, notice that if I were to kind of plug infinity into x squared, essentially that means I'm plugging larger and larger and larger numbers into x squared. Well, as I continue to plug larger and larger and larger numbers into x squared, I'm going to have 3 times extremely large numbers, which is going to give me a result of large numbers back. So I will say this limit does approach infinity. That's it for this video. That's just, like I said, kind of the introduction. If you watch the next one, we'll look at some more complex problems where we're taking the limit as x approaches infinity.